So let's go ahead and get started. So thank you everyone for attending today's session, The Future of ERP Analytics with Automated Machine Learning. Today we'll look at how automated machine learning is changing the playing field for data professionals. And what I'll show you today is the future of BI and analytics platforms enabling analysts to derive advanced insights from data. So my name is David Kettinger, and I work for a company called Preferred Strategies. We were established in 2002 in the San Francisco Bay Area, and our quick launch solution bridges the gap between ERP systems and the market-leading analytics and reporting platforms. All right, so a little bit about myself. I started my career analyzing financial investments, and after seeing how rapidly the analytics field was evolving, I decided to really take the leap into data analytics when I pursued my master's in information system at the University of Colorado. And ever since then, I've been keeping a constant pulse on the analytics industry. So let's look at what we'll cover today. So we'll start out with a brief introduction to what data science and machine learning is, and then we'll look at how these fields are being applied to the business. We'll then jump in and see how business analytics has evolved and how these machine learning technologies are being integrated into modern analytical platforms. And then we'll jump into demo, and we'll see how these features are being used over ERP data, and specifically we'll be using Microsoft's Power BI platform to show you that. We'll then summarize how Preferred Strategies can help you get started using these tools, and then lastly, if we have time, we'll look at how you can actually create your own machine learning models within the Power BI platform. Okay, so let's go over a few definitions before we move forward. So artificial intelligence is the catch-all term that refers to scenarios where a machine mimics the functions of human minds, such as learning and problem solving. So when we talk about machine learning, this is really a type of artificial intelligence that gives computers the ability to learn without being programmed to do so. The general principle here is to apply a statistical algorithm to a large data set of historical data to uncover relationships between the fields. So data science is an interdisciplinary field that uses scientific methods and algorithms and computer systems to extract insights from large volumes of data. And data science really combines computer science with math and statistics, and most importantly, business domain knowledge to enable data-driven decision-making. So a few years ago, Gartner defined a citizen data scientist as a person who creates or generates machine learning models that use advanced analytics to answer business questions, but whose primary job function is outside of the field of analytics or machine learning. I like to think of it kind of like WordPress for data analytics. So just like WordPress allowed anybody to create a website within a few clicks, without needing a degree in web development, citizen data science attempts to do the same thing for data analytics. And the goal is to create a platform upon which anyone can extract insights from data using AI and machine learning technology that's already been integrated into the analytical platforms. Okay, so as consumers, we are exposed to AI every day, from your Netflix recommendations to your Google Maps route. The intelligence behind these predictions is powered by machine learning algorithms. So according to Netflix, 75% of the content that people watch is based on their recommendations, which uses machine learning models to rank and classify content based on what the algorithms think you'll enjoy. And similar technology is used by companies like Amazon to predict and recommend items that are often sold together or related items that you might also be interested in. There are many applications of data science that your company can benefit from. You can use machine learning models to match bank payments to AR invoices. You can create a churn risk model to tell us what customers are likely to stop using our product or services. Another good example is centered around equipment monitoring and predictive maintenance for manufacturing. And we can use machine learning to predict when a piece of equipment is going to fail, so we can take some action before it actually does. And furthermore, we can use prescriptive analytics to determine what part is going to fail, and then submit a service ticket to our maintenance team so they can go in and fix it before a failure actually does occur. So the goal in most organizations is to move from traditional descriptive analytics, or what happened and why, to predictive and prescriptive analytics, which tells us what will happen and what we should do when it does happen. The problem with this picture is that when we go up in the value to the business, or the y-axis, we can see that we're also increasing the difficulty involved. However, with new technologies that automate machine learning, analytical tools are enabling analysts without the programming skills or the degrees in data science to leverage advanced analytics. So this is the traditional analytics maturity curve, and this particular version was introduced by SAP a few years ago. And the basic premise is that as your analytics maturity increases, so will the competitive advantage that your business has. And as you can see on the left, you have your descriptive and diagnostic analytics, or what happened and why. And then as we go up in the maturity curve, we have our predictive and our prescriptive analytics. And then lastly, we have our autonomous systems, which is systems like self-driving cars. And in the middle of these two groups, you have this chasm, or this deep divide, which many companies struggle to cross over because of limited data skills, resources, and technology. And you can imagine it like on the left of the chasm is looking into a rear view mirror, and on the right is like looking into a navigation system. So while it's important to know where we're coming from, it's even more important to know where we're going. So if we break these down a little further, on the left here we have analytics powered by humans for humans, and really this involves collecting relevant data from different data sources and translating those into business terms, and really exposing aggregated levels of information to business via reports and dashboards. And then ultimately, your users then make decisions based on what they see and take appropriate actions, hopefully. So on the right, we have our predictive and prescriptive, which usually entails analytics powered by math or statistics for business process. So usually the goal is to create a predictive model that is then automatically applied to new data as part of some automated business process. For example, when a bank uses a predictive model to check the possibility of a fraud each time you use your credit card, or when a retailer like Amazon determines what product to cross-sell you, they're automatically embedding that into the e-commerce experience. So instead of making the data intuitive for humans, it needs to be prepared for algorithms, which means normally we have to flatten or denormalize the data and include as much detail as possible. And this usually takes a little bit longer time due to the large amounts of data required and the time to build and train predictive models. The last step on the maturity curve is really analytics powered by mathematical algorithms for autonomous systems. For example, self-driving cars use constantly updated algorithms to navigate and drive with little or no human interaction. Similar algorithms are used for the breakthroughs in human-machine interfaces that we've seen over the past few years, like digital assistants such as Alexa and Siri. So in the past 2 or 3 years, we've seen a surge in a new segment that uses automated machine learning features built into analytic software platforms, and is referred to as augmented or smart analytics. So advanced algorithms are being used to augment the traditional analytical process. For example, they can be used to correlate different data within your data sets. They can automatically spot what's statistically significant or unusual about a data set, and even group data into automated clusters or natural segments. And so this new segment helps businesses gain more competitive advantages or value from their analytic systems without needing the additional skills or resources to cross that chasm or divide. And so in our next demo, we'll look at how many of these new features are being incorporated into the Power BI platform. Okay, so in this demo, we'll see how we can apply some of these new technologies connected to some sample ERP data. And we'll take on two personas. The first will be that of the VP of sales for our fictitious consumer electronics organization. And we will walk through consuming insights within Power BI. And in the second role, we will switch to an analyst and see how augmented analytics can help create some compelling reports and dashboards. Okay, so I'm going to switch over to a browser and go to powerbi.com. And powerbi.com is the software as a service component of the Power BI platform, where we collaborate with colleagues and ultimately share and distribute our information throughout our organization. So as the VP of sales, I'm going to consume my information here in an app, which is basically a packaged up set of related reports and dashboards and data sets, and is intended for distributing to end users or read-only users. So if I click on my Sales Analytics app, you can see it takes me to this VP of Sales dashboard. And a dashboard in Power BI is our single view into the health of our business. It's that single pane of glass into how we're performing, and then we can pull data from many different data sources into a dashboard. So in this particular case, we have information coming from our sales data set as well as our inventory data set. And I can quickly see, just looking at this, that I have an issue with my gross profit percent versus our prior year. So you can see our margin is down. So let's look at how we can use automated machine learning features to kind of help explain what's going on here. So if I click on a visual or a tile on the dashboard, it's going to take me down to the underlying report that was used to create that tile. Now I can have my traditional ad hoc exploration experience that many of you are probably familiar with. So I can come in here and I can change this. Instead of looking at it month to date, I can change it to be year to date, right? And I can start to change these different slicer values. And it's also fully interactive. So if I click on a data point in this visual, you can see it update the rest of the visuals on the page. And I can also do other types of exploration that is sort of standard to BI. I can click on, I can hover over a data point and get some report tooltips to give me some additional context around that data element. I can also right click and choose to drill down, so I can go in to see the next level within the hierarchy of this visualization. So I can go from the sales rep down to my different product groups, and then I can drill back up. And then I can also, instead of drilling down, I can right click on this and I can go to drill through, and I can choose to drill through to the sales order details page of our report here. And then I can, this helps me go from a more aggregated level of analysis down to that more detailed grain. So in this case, we're going down to the order number, order date grain of our sales fact table here. And I can choose to go back to the report using these navigation buttons, similar to like a web app experience. And instead of going down to the sales order details, maybe this time I want to go to the sales rep analysis page. And so what that's going to do is it's actually going to pass that sales rep filtered through to this page. Now I'm looking at the sales rep analysis for David Williams here, and you can see some different automated machine learning features right off the bat here. So we can see that we have over on the right a natural language generation visual that's dynamically writing a summary of the analysis that we're seeing on the page. And this is all going to be interactive. So as I click around on the different data points, it's going to update my narrative on the right. So you also notice that I have a sales trend feature over here. and right now it's set to show anomalies. And so this is a feature that came out a few months ago in Power BI to automatically detect when a data point falls outside of the expected range of values here. So I can see I have a few anomaly data points here for David Williams. And I can see that on September 1st of 2019, the sales amount fell outside of the expected range of values. And if I click on that anomaly point here, you can see that over on the right, it's actually trying to explain this anomaly, and it actually has some natural language generation going on here, saying, summarizing what the anomaly is. And so I can come over here and I can click on these different cards or these explanations to try and see what's going on and why we might have had this particular surge in sales. So you can see here that when we sold refrigerators, which is part of the product subgroup field, this had a correlation or a strength of 79%. And I can actually click on the drop-down arrow here, and I can get a sort of a visualization and summary of what happened. And you can see that indeed on this particular date, we had a spike in refrigerator sales, so which kind of helps me explain perhaps what's going on with this data point. So in addition to the anomaly detection here, I can also choose to show a forecast. And so now I have a forecast feature built into a standard line chart of Power BI. So without having to know how to do any sort of forecasting algorithms and apply that, it's just a few clicks, and I'll show you that in the next part of the demo. But again, this is all interactive, so now I can click around on this and see how my forecast performed. Okay, so let's go back to our initial sales overview page. Now I want to, again, try to explain why my profit's fading or why my margin is decreasing. So if I come in here, and I can see I have this button here that says click here to get more information. And when I do that, you'll notice that I have, it takes me down to this profit trends page. And I have, again, a few different machine learning components built into this page as well. So I have my forecast for gross profit percent. I also have my natural language generation visual going on, is summarizing that trend, so I can quickly read and get some metrics there. And then I also have this natural language query visual called Q&A in Power BI that I can come and I can just type in natural language what I want to see. So in this case, if I want to, maybe I want to break this out by my different states. I can come in here and say, show me gross profit percent, if I can spell, by state. And you can see even it tries to do some guesses on what you mean when you misspell stuff, which I do quite often. And now you can see that I have, if I click off of this, you can see I have my different states and their gross profit percent values as well. And I can even try to refine this if I come in here and say, maybe I could do some bottom 3 analysis. Now you can see that just by typing in natural language here, I can see my worst performing states for gross profit percent. So if I click down here, you can see Illinois has the lowest profit margin here, and if I click on that, it's going to update my visuals over here, and I can see that within the last month that the profit decreased quite significantly. So what if I want to try to explain what's going on here? I can right click on the data point and I can choose to analyze and explain the decrease. What that's going to do is it's going to run some machine learning algorithms over the data set to try and figure out why the gross profit percent decreased by 42% between October and November here. And I can scroll down, you can see I have a lot of different insights here that I can go through, but once I find one that's compelling, I can read through it. And this one is explaining the profit fade by our different product groups. And so I can see here for appliances that we had a decrease within that time frame of around 50%. And then for TV home video, it looks like we had a 40% decline. So maybe I want to get in touch with these division managers and figure out why we're having these issues. All right, so I'm going to continue on with my analysis here. I'm going to come to the next page of my report here just by clicking on this link over here. And now you'll notice that we have this visual that's called a decomposition tree that helps me do some root cause analysis. So now I can try to get to the bottom of what's causing my gross profit to in this case, decline. So I can choose to break this out by different fields that have been defined within the visualization, or I can choose to use the AI components built into this visual to automatically find the field with the lowest value for gross profit percent. So if I choose low value here, you can see that and scan the model here and determine that when we sell our side-by-side products, we have the lowest gross profit percent. And so now I can continue on and digging into this, and I can choose to go further and say, hey, show me the lowest value within that side-by-side product. And you can see here that when we're selling to New York and Atlanta, it seems like we're having the lowest profit margin. So maybe I want to get in touch with those regional managers and figure out if there's a supply chain issue or if they're having cost overruns in certain areas, and try to take some action and figure out what we can do to correct this. So the last standard AI visual within Power BI that I want to show you is called the Key Influencers visual. Again, this is just available out of the box, and for this particular visual, we can set a metric up to see what fields within our data set are influencing this particular metric to either increase or, in our case, decrease. So I can set that to decrease, and now it's applying those automated machine learning algorithms over our data set and determine that when we sell our Galaxy Tab S3 product, the average gross profit percent decreases by 33.7%. And then over the right, we can see how that particular product is performing against other products. And then you can also click on different influencers that it's found. In this case, when we sell refrigerators or a product subgroup, our average gross profit percent decreases by 25.46%. All right, so let's switch gears now, and we'll look at how we can add a forecast for sales to our dashboard. So as the VP, I want to call out my my analyst. So I can come in here to comment, and I can actually come in here and mention my analyst. So I can say, hey David, can you create a sales forecast for VP of dashboard? And then I will get that notification once he submits that comment, and then I'll know to go out to this particular piece of content and update it. So now as the analyst, I'm going to come in here and try to add that sales forecast visual to the VP of Sales dashboard. So what I'm going to do, instead of going to the app here, I'm going to come back to my Power BI home screen, and I'm going to go to a workspace. So a workspace in Power BI is our collaboration or development area for people who are actively, developing, testing, and working on reports and dashboards and other artifacts that we'll discuss later on. So what I can do is I can come to this sales analytics report that my VP of Sales wants me to update, and I can come to File and download the PBIX file, which is the extension that Power BI uses to save its files. And then once I've downloaded that, I can open it up in the Power BI desktop. And the Power BI desktop is the development tool within the Power BI ecosystem that we use to create our reports and even create data models as well. All right, so I want to add a new page here. So I'm just going to come to the plus button over here and choose to add a page. Maybe we'll want to call this our sales forecast page. And now let's look at how we can quickly add some analysis to the report here. So instead of dragging a field on from our fields pane or adding a visualization, look at how the natural language processing is being built into this experience as a developer as well. So I can just double click on the canvas here, and you can get that similar Q&A experience that we saw in the Power BI service. So I can come in here and say, hey, show me my sales amount by my year period. And I could choose enter, and you can see that Power BI has determined that I'm trying to trend a measure over a time field within my data model, and it chose to display this as a line chart, which is actually what I wanted. So if I like this visual, then I can choose to turn this result into a standard visual on my report page. And so now within typing in a few words, I've already created this trend visual without having to know how to navigate the data model and add those particular visualizations. So what if we want to add some more analysis to the page? I can double click again, and maybe this time we'll do our sales amount by sales rep. And I misspelled that. So we have a measure broken out by a categorical dimension, and Power BI has determined that the column or bar chart is the best visualization based on those fields, and that's actually what I wanted. And so now I can see my sales amount by my different sales reps, and now this is all interactive, so I can click around and start to use it just like any other standard visual in Power BI. All right, so let's look at how we can add some of those augmented analytical features to our visualization. So if I click on the trend chart and come over here to the analytics section of the visualizations pane, you can see I have a lot of different dynamic elements that I can add to my visualization. And you'll see here that I have my find anomalies and also have my forecast. So just to show you how easy it is to set these up, if I come over here to the find anomalies and choose add here, you can see that it's created this expected value range on top of my visual here. And I can set some parameters as well. And at a 70% sensitivity level, it hasn't determined that there's any anomalies. But if I increase this to, let's say, 86% sensitivity level, maybe it didn't go high enough. Let's go to 90%. You can see now that I do have an anomaly for this particular time period, and I can click on that anomaly and get a similar experience that we saw in the Power BI service, where we have our trend visualization up here and that natural language description of what's going on, and then Power BI has gone and scanned the data set and tried to just bring back some generic fields to possibly explain this anomaly. But I can customize this pretty easily, so I can try to explain this by certain fields that I know my users are going to be interested in. So I can come to the customer table here and choose to explain it by sales rep or region or customer name, and maybe I'll choose my channel as well. And now I can choose to apply that, and it's going to automatically just filter down these possible explanations to fields that I'm interested in. All right, so the purpose of this exercise was to add a forecast. So I'm going to delete the anomaly feature here and come to a forecast, and I'll choose to add a forecast. In this case, we're going to forecast out for a quarter. So I'll come in here and I'll choose 6 months, and we're going to choose to ignore the last 3 months so we can see how valid our forecast algorithm is. We'll keep it at 95% confidence interval, and we'll change the seasonality to be 12, since there's 12 months in a year. And now we can see, chose 6 quarters instead of 6 months. I'll choose to apply that change. And maybe we want to format this a little bit as well. So I'll make it orange, and I'll make it dashed here. So now again, this is all dynamic. So as I click around here, maybe you want to see how different sales reps are forecasting. I can click on that, and you can see the forecast is dynamically changing based on what I select. Okay, so let's add a few more elements here to this page. I'm going to double click down here, and let's say I want to add some gross profit information to this as well. So I'm going to choose sales amount and gross profit percent by product. And so now Power BI is looking at the fields that I've typed and determined that, hey, he's typed in 2 measures, but by dimension. So maybe he wants to see a correlation between those two measures, and so that's why they chose a scatter chart. And so this is actually the one I wanted. So I'm going to choose to turn this into a standard visual on the page here, and let's look at how we can spice this up a little bit. So I'm going to come in here to my category labels and start to format this just like any other visual in Power BI. And maybe I want to add some additional information that I didn't put into my original query. So maybe I want to size these data points by my gross profit dollars. So I have my gross profit percent as the y-axis, and then I have my gross profit dollars as the size of the data points. And just so you can see this a bit better, I'll hit the focus mode here. And so now, what if I want to find some natural groupings within my data? I can come in here to the more options here and choose to automatically find clusters. And so, you know, without having to know what k-means clustering algorithms are or how they work, and come in here and start to configure this new grouping of products here within a few clicks. So I'll call this my product segment, and I'll set the number of clusters to auto and choose OK. And so what this is doing is actually augmenting my data model and adding a new field in the data model via this automated machine learning feature. So if I come here to my item branch, which is where my product group lived, you can see they actually created this product segment field within my data model. And I can start to edit this just like any other field in my data model. I can come in here to edit clusters, and maybe I want to provide a little more context behind these different clusters. So you can see cluster 1 might be my high margin products, and you can see cluster 2 might be my low margin products, and then cluster 3 over there in the green might be our top performers. And then I could choose OK here, and you'll see that the legend up here is going to update to show me those different names for our clusters here. And I can come back to the report. And the cool thing about having this new field in my data set is now I can start to use this in other visualizations. So if I want to maybe see how my sales reps are performing across our different product segments, I can come in here and add it to the legend. And now you can see that we can see Jason Lee sells more of our low margin products, and David Williams seems to be selling more of our high margin products. And so that's how we can use this within our analysis. And as we click through this, you'll see that it actually updates based on these different product segments that we choose. Okay, so getting close here to sharing it, but I know here that we have a decrease in our sales between November and December here. So I know my VP is going to want to know some insights into why this happened. So if I come in here to analyze and explain the decrease, I can get that similar experience that we saw in the Power BI service, but as a developer or designer of reports here, I can actually use this experience to create my report. So in order to explain the 25% decrease in sales amount between November and December, I can scroll down here until I find some insights that are relevant. I actually don't have anything for customer on this analysis, so maybe I want to add that. And you can see here that Overstock, Listen Up, and Sears had the largest decrease among our customers, which offsetted the Wenger Electronics increase. And so if I like this visualization, I can choose to add it to my report. You can see there's also some other visualizations options as well. And so if I hit the plus button up here, without having to know how to create a waterfall chart and format this visual, it's automatically created this as a standard visual on my page. And again, now I can start to click around on this, and you'll see the values are updating based on the different data points I select. So now that we have the analysis ready to be shared, I'm going to come to publish this. And what that does is it's going to publish this PBIX file to the Power BI service, and we'll be able to share that with our VP of sales. So what we need to do is choose the workspace that we want to publish it to. So I'll choose that Sales Analytics workspace and choose Select here. And you can see here that it's saying, hey, do you want to replace this report? And that'll impact also a dashboard, and we know that. So we're going to go ahead and choose to replace that. And so once this is published, we'll be able to go and see this these new updates that we made within our sales analytics report. So I'll choose to come back to my browser here, and I'll just choose to refresh this page here, and then we should see our new sales forecast page here. And I could select that, and now we have our new analysis here ready to go. So I'm going to go here to the pin visual icon here and choose to pin it to my VP of Sales dashboard, and then choose OK, and then we'll go to the dashboard. And now you can see this new sales forecast has been added to the VP of Sales dashboard. And so now I'm ready to share this with my VP of Sales. So I'll come back to the Sales Analytics workspace, and I'll choose to update the app. That was how my VP of Sales consumed this data. And now I'm ready to, I can ping my boss or ping the VP of Sales and say, hey, your new updated dashboard is ready for you to consume. Okay, so let's jump back into our PowerPoint here and continue on. So if machine learning is so great, then really why isn't everybody doing it? Well, there are a few challenges facing organizations attempting to adopt machine learning. And first, there's just a massive amount of data that you have to manualize. You have data coming from on-prem relational databases like ERP systems. You have cloud data from IoT devices, social media, and SaaS platforms, and the list really keeps growing every day. Next, there's a shortage of people that have the PhDs in data science and that have the skills to model all of this data effectively. And even if you're lucky enough to get this far, you then have to figure out how you're going to actually operationalize this within the business to produce value or produce some return on investment. So generally, when we think of data scientists, we think of them spending their day building algorithms and exploring data and doing predictive analysis, but this assumption is really not true. According to a recent study, in most companies today, 80% of a data scientist's time is spent just collecting data and then cleaning and organizing that data. So this is the traditional data science workflow, and as we sort of just discussed, to truly get the value out of data, you need to know how to properly extract it and relate it and model the data into an analytics-ready state. And this is where our quick launch solution really shines by helping you transfer that data into actual information and giving you the best practices and methodologies in order to tie different corporate data sources together, and then load that into your ETL or prep stages. So we have an operational data store option to the quick launch solution, as well as a full-blown enterprise data warehouse that we can use as our single version of the truth when we're connecting and beginning to create our analytical models. So again, our quick launch is sort of transforming the ERP backend. We're taking cryptic table names and renaming them to be business friendly, and converting dates and doing decimal precisions and renaming UDCs into business friendly terms. And so we're really accelerating the time to insight for your analysts. All right, so this takes us to our last demo, and that's going to look at automated. In Power BI, they have a feature called AutoML, which allows us to generate machine learning models within a user interface that's a no-code environment. And then we can train and test those models and review the results, and then ultimately apply that model to some data so that we can consume some insights in reports. So let's look at this in action. I'm going to come over here to my browser again, and I'm going to come to back to the Sales Analytics workspace. So I'll come in here to that workspace, and in this particular demo, we're going to look at a feature called a data flow. And a data flow in the Power BI service is really a self-service ETL artifact that we can use to connect the data and then pull it into the cloud. And so what this is doing is it's actually taking our data and storing it into an Azure data lake that's tied to our Power BI tenant. And so now I can perform these advanced analytic features right on top of our data here. So in this particular example, we're going to look at how we can predict whether or not somebody's going to buy a bike from us, and if this is actually part of a workshop that a company called Blue Granite did a few months ago. And if you'd like to walk through it yourself, I recommend you go check out their AI in a Day sessions that they did, and I have a link in the references in the slide deck, which we'll make available to you after the presentation. So what we have here is really two entities that we start out with. We have our historical data on our prospects and customers. So we're taking demographic data from our historical prospects, and then we're adding a field into that says, did the person buy a bike or did they not buy a bike? And so we look at for people that or prospects that in the past that did buy a bike, we mark it as a 1, and for people that didn't buy a bike, we'll mark it as a 0. Then what we can do is use this to build and train our model. And we also have some current prospect data that we want to use to then predict whether or not they are likely to buy a bike from us or not. So that's the setup for this. And if I come here to machine learning models, I can come here to add a machine learning model, and you can see here within, it's a pretty intuitive experience. Within 4 steps, we can create and train our new automated machine learning model here. So we want to choose an entity here. So we're going to use that historical bike training entity or table to train our model with. And I'm going to come here and choose my outcome field, which is that bike buyer field. And then I'm going to choose next here. And what this is going to do is that it's going to scan the data set and what I'm trying to predict, and choose the best type of algorithm to use here. So you can see here it shows the binary prediction model here, but if I come to select a different model, you'll see that I have some other options as well. So binary is true or false, buyer or not buyer. The general classification is for trying to predict or classify people into 3 or more groups. So good credit, average credit, or bad credit, for example. And then we have our regression, which estimates a numerical value like sales or house prices. But we're gonna stick with Power BI's recommendation here and choose to use the binary prediction. And we're gonna try to predict whether or not somebody buys a bike, and that's what we're most interested, which is that 1 value that I mentioned earlier. So then we can try to add some additional context to this in labels. So I'm going to call this the buyer, and then when it's not 1, that's not a buyer. And then we can choose next here. And so here it's gone and tried to do some automated feature selection, or gone through the different fields within the table and tried to find whether there was a strong correlation between the bike buyer field and these other fields here, and recommended that these ones have the highest correlation. But this is all customizable. So if I wanted to include these other fields to kind of do my exploratory analysis here, I can choose those as well, and then choose next over here. And now I can give this a name, and then I can Oh, I've already done this, so it's going to tell me that's not acceptable. And we can choose to set the training time as well. So obviously, the longer we train the model for, the more iterations it can go through, and the more accurate it'll be. But just keep it at the default level here, and we could choose save and train, and that's going to go ahead and begin the training process of our data model here. Okay, so I've already done this, and you can see here I have my bike buyer prediction model here, and what we can do now is go and look at the report here. So I can click on View Training Report, and it's going to load up a report that summarizes the performance of the model, as well as certain details that are relevant to the outcome here. So you can see here it's on the training details. Let's come over here to the model performance tab of this report here. And we can see right off the bat the model performance was 81%. And that's the area under the curve, which is used for model performance classifier models. And 50% would be sort of like flipping a coin, and obviously 81% is well over that. So it's a pretty decent model here. And I can also start to tune some parameters here. So depending upon the type of analysis that we're trying to do, this might influence what we select here. So if we're an insurance company and we're trying to predict whether or not a certain transaction is fraudulent, then we don't want to have a lot of false negatives. And so a false negative would be when we're predicting something is not fraud and it actually is. That could be pretty detrimental. So what we could do is we can increase the recall percentage here and tune this model so that we're avoiding our false negatives, which obviously results in more false positives. But again, as that insurance insurance company, we're optimizing this for that particular business case here. So I can also let's say for this particular bike buyer, I'm actually creating this model to help with my marketing efforts. And so I can actually come in here and increase the precision, and you'll notice that the false positives lowered tremendously. So if I'm trying to avoid spamming people, then I don't want to predict somebody's going to buy something from me when they're actually not going to buy from me. So I'm going to lower that false positive rate so that we can have a more targeted marketing effort. So I can also come over here and see some top predictors. So I can see, looks like marital status, age, and number of cars seem to be the top predictors, and I can select this and start to explore these different features and how they are influencing whether or not somebody's going to buy or not here. And then I can come over and I can see more information on the accuracy of the report, get more insights into that. You can also see the training details. So if I want to see what the actual name of the algorithm was that was finally used, I can see that. I can see the iterations that it took during the training process. And I can use this, if I have a data scientist on my team, I can use this to pass along to them and get more detailed insights into how we actually created this model. And when I'm ready to apply this model, I can come to apply here. And what that's going to do is allow us to take this prediction scores and apply that to our prospective buyer data set. So what I can do is choose the prospective buyer entity here, and we'll keep the column name at bike buyer prediction. And here we have that threshold that we sent. So if the predictive score is above, in this case 78%, then we'll mark them as a buyer. Else they'll be a not buyer. I can choose to save and apply that. And if I come back over here, you'll see that I have these entities that were created when we apply this, which is the prospective buyers enriched by the machine learning model. So now what I can do is I can come into Power BI Desktop and connect to that entity and create a report here. So now I'm looking at whether or not somebody's predicted to be a buyer or not, and we'll set that to true, and we can see some breakdowns of our different predicted buyers here. So the first one we have is our predicted buyer by state. So you can see that on the west, it seems like we have a lot of potential buyers here, and I can start to click around on this and segment my report here. So I can click on these 3 different western states: California, Oregon, and Washington. You'll see that the rest of visuals have been filtered down to that, and I can look and see that, well, it looks like a lot of single people are predicted to be buyers. So I can continue on segmenting this, and you'll see my list of prospects is being filtered down as well. And maybe I want to just target males for this particular marketing campaign. So I can control click on that data point as well. And now what we can do is we can actually see our list of prospects as being filtered by the segment that I just created through these different click paths. And I can come over here and I can do an export data, and that's going to export this segmented list of potential prospects into a CSV or Excel document. I can actually use that to pass through to my marketing platform in order to quickly create this marketing campaign based on this machine learning model that we built. All right, so that is the end of that demo. Let me come back over here and just wrap up. So there's some good documentation on Microsoft's website about AI with data flows, as well as other machine learning features within Power BI that I recommend you go and check out. Here's a link to that SAP blog that discusses the analytics maturity curve that we talked about earlier. And then we have that AI in a Day by Blue Granite, which is a great walkthrough into how you can create those AutoML models in Power BI. So with that, it takes us to the end of our session. I'm checking to see if there's any questions here. So one question is data flows an extra part that needs to be purchased? So if you want to use, so data flows is available for the standard Pro licenses as well. But if you want to use the automated machine learning features on top of the data flow, that's when you need to have a premium Power BI premium license. And so typically or historically, the premium, so Power BI Premium is an additional subscription service that offers more enterprise grade features, and traditionally that it started out at a price point of around $5,000 a month, but with the recent addition of the Power BI Premium per user licensing, this is going to be much more affordable. And so this is actually in public preview right now, so you can actually go get a free Power BI Premium license right now while it's in public premium, and you can assign a workspace to Premium using that per user license, and you can take advantage of all of these Power BI Premium features, including AutoML, basically for free right now. And then they haven't released the pricing yet, but I think it's going to be pretty reasonable, especially compared to that $5,000 price tag. All right, so I know we're running up on time here. It doesn't look like we have any other questions. So with that, I will sign off. And again, we'll make this presentation available on our website. And if you're interested in the slide deck or any other questions that you want answered, feel free to reach out to us. So thank you, everybody, and hope you have a great rest of your week.